Okay, my stream got got cut off halfway. So we were looking at this example of executives who are loyal or not loyal, and how many years the executive has had in the service. Okay, so here we looked at the previous example when we are thinking about someone who's older than 10 years and would remain within the company. Okay, so what's the probability that a person you selected is both of these? That would be given as 75 divided by 200, which is 75 divided by 2, which is 0.375. If you want to try and think about that in a conditional probability sense, so that's the probability of A1 and B4. The probability of A1 and B4 is probability of A1 occurring and the probability that B4 occurred given that A1 has occurred. Okay, so that's this way. You could write the same probability of A1 and B4 occurring. Probability of A1 and B4. So this could also be written as the probability of B4 occurring and the probability of A1 given that B4 has occurred. Okay, so you could write the whole formula this way. So what's the probability of A1 over here? It's 120 divided by 200. 120 divided by 200. Okay, so when we are trying to do the reverse way, here's going to be the probability of B4. Probability of B4 is going to be 105 divided by 200. And the probability of A1 given that B4 has occurred. So in the previous scenario here we did the probability of B4 given that A1 has occurred is 75 divided by 120. But now it's going to be 75. We are looking at the probability that A1 is going to occur given that B4 has already occurred. So B4 has already occurred. That means you're looking at only all the total number of people within this B4. That's 105. And within this 105, how many remains and how many does not remain? And we're looking at A1 given B4. We're looking at A1 that those would remain loyal. So this would be 75 divided by 105. Okay, so in both scenarios, this is 75 divided by 200 is the final answer. Whereas the numerator, and the parts ever so slightly changed. Here was 120 over here and 120 over here. Whereas in our example, it's 105 and 10. Okay, but the other two parts, your final answer still remains the same. So this is another way to try and do the same problem using a slightly different variation of your general multiplication rule. So now let's try and look at another question which is asked over here. So now what's the probability? So far we've been asking the and. What's the probability that A occurs and B occurs? So now let's go back to the addition rule. So what's the probability of selecting an executive that would remain or has less than 1 year of service? Okay. So now we are trying to do the idea of probability of remain, which is A1, or has less than 1 year of service, which is B1. Now you're being asked for this question. So this becomes the probability of A plus probability of B1 minus probability of A1 intersection B1. And the probability of A1 is 120 divided by 200. Probability of B1 is 35 divided by 200 minus the intersection between them is 10 divided by 200. Okay, so that's what we have right now, and this would be the probability of A1 or B1 occurring in your textbook is here, which is 0.725. Okay, and so this is the two ways this contingency table can also help with your addition and your multiplication. Okay, so that's a nice way to try and solve problems. The final thing, the same problem which we looked before, you could represent it in a tree diagram as well, in terms of remain, would not remain, and then trying to do more questions here. But you could also draw the same tree diagram in another way, where you could start off with 4 matches. Okay, so here it's remain would not remain. So here it would be like B1, B2, B3. Okay, so here it's like 10 years, greater than 10 years of experience, 6 to 10 years, 1 to 5 years, and then less than 1 year. And with under each scenario, you could do remain, not remain. No, so remain, not remain. And you could kind of create these this way as well. And you would still, and when you add up all the probabilities under each scenario, it'll add up to 1. You could get the same result using a tree, just drawn slightly differently. Okay, so this is the idea of probability trees, and there's some problems given to that. And you could try and work out this problem, the self-review problem, using both methods and kind of verify that. Okay, so that is it for chapter number 4, and then you'll be moving on to chapter number